Okay, now already we have done about the Markovnikov addition, Markovnikov rule. Markovnikov rule is applicable only in the addition reaction to an unsymmetrical alkene. But in the Markovnikov rule, there is one effect which is called peroxide effect. Peroxide effect. What is this effect? In the addition to an unsymmetrical alkene, this is also a part of Markovnikov rule. In the addition to an unsymmetrical alkene in presence of peroxide, here peroxide will act as catalyst. In presence of peroxide, peroxide, you know, there are a number of peroxide. Actually, peroxide means those compounds which contain oxygen single bond. For example, hydrogen peroxide, sodium peroxide, you will get oxygen single bond. So in the addition to an unsymmetrical alkene in presence of peroxide, Anti-Markovnikov rule takes place. Anti-Markovnikov rule takes place. This is called peroxide effect. It is also called Kharas effect, Kharash. It is also called Kharas effect or peroxide effect. I mean, what is this effect? Like, this is one alkene, unsymmetrical alkene, and suppose you are adding one hydrogen halide HBr. As you know, here H is plus, Br is minus. According to Markovnikov rule, the negative, Br minus, it's added with that double bonded carbon atom which contain less number of hydrogen. So Br will be joined with this and hydrogen will be joined with this, and the double bond is converted to single bond according to Markovnikov rule. But if the reaction is carried out in presence of peroxide, if peroxide is present in your reaction, then Markovnikov rule become opposite. Negative is added with that double bonded carbon atom which contain more number of hydrogen. Br minus will be joined with this carbon, H will be joined with this carbon. You will get the product like this. Hydrogen is joined with this carbon, bromine will be joined with this carbon, and the double bond is converted to single bond which is called 1-bromopropane. Markovnikov rule become opposite in presence of peroxide, and this effect is called peroxide effect. In the addition to an unsymmetrical alkene in presence of peroxide, the negative is added with that double bonded carbon atom which contain more number of hydrogen, which is opposite to Markovnikov rule. That's why it is called Anti-Markovnikov rule, and it is also called peroxide effect. Now, why the Markovnikov rule become opposite in presence of peroxide? See, in exam, if you get the reaction this plus this, you see where peroxide is present or not. If peroxide is absent, you apply Markovnikov, and if peroxide is present, then you apply Anti-Markovnikov rule. So now why it becomes opposite? Actually, in presence of peroxide, the breaking of bond always takes place homolytically. I have given, there are two types of breaking of bond. One is called homolytic, one is called heterolytic. Homolytic breaking takes place in case of gaseous reaction, and the gaseous reaction should be carried out in presence of light, heat or peroxide. Here, due to presence of peroxide, the breaking will take place homolytically, and due to homolytic breaking, here you don't get any electrophile, nucleophile, you will get some free radical, and due to this reason, the Markovnikov rule become opposite. I will show you. For example, this is your peroxide. The name of this peroxide is benzoyl peroxide. This is called benzoyl peroxide. Suppose that this peroxide is present in your reaction as catalyst. Here oxygen contains single bond, that's why it is called peroxide. So first time, this peroxide will break homolytically like this. It will form some free radical. It will get C6H5COO dot. And another one you will get C6H5COO dot. You will get two free radical. First time the peroxide will break like this. After breaking of this, again it will break and it will break like this. This bond will break. One electron, this odd electron come from this to this position, and this bonded one electron come from this to this, and one electron come with this. I mean this bond will break. Here it will form double bond. I mean you will get CO2 as the product, and here you will get one free radical which is called phenyl free radical plus 2 molecule of carbon dioxide will release. So first time the peroxide will break in this way. Now after formation of this phenyl free radical from the peroxide, this phenyl free radical will break the HBr molecule. When it added with HBr, it will break like this, homolytic again, and this odd electron combined with hydrogen odd electron, it will form a bond between carbon and hydrogen. I mean it will convert it to C6H6, which is called benzene, C6H6, plus you will get one bromine free radical, Br dot. Now this bromine free radical will combine with your alkene. So this is our alkene, propene. When this propene combines with this Br dot, how it will combine? First time this pi bond will break in the alkene. One electron comes towards this carbon, another electron goes towards this carbon, and the bromine electron may combine with this electron, or this bromine electron may combine with this carbon. Have you got it? I mean this odd electron combine with this odd electron, or this electron combine with this electron also. When this electron and this electron will combine, then the CH2 will join with bromine, and if this electron combine with this, then CH will join with bromine. So there are two products you will get. Either you will get this one, then here dot will be present, or you may get this one. If bromine joined with this, then the dot you will get in this position. Have you got it? So there are two possibilities. Bromine may be joined with this carbon, or bromine may be joined with this carbon. Now after joining bromine, this is one free radical, this is another free radical. This free radical is secondary free radical, and this free radical is primary free radical. As you know, secondary free radical is more stable. It is more stable, and due to more stability, this is your main product. And that is why the bromine will join with that double bonded carbon atom which contain more number of hydrogen. And the H dot again coming from benzene, this H dot again combine with this carbon to get this product. So that is why if peroxide is present, then the Markovnikov rule become opposite. Normally in Markovnikov addition, heterolytic breaking takes place. That's why some electrophile and nucleophile will form. So the mechanism was in that way. But in presence of peroxide, homolytic breaking takes place, and due to this homolytic breaking, some free radicals are formed. That's why the mechanism will be something different, and that is why here the secondary free radical will be more stable, and that is why bromine will join with this first carbon. I mean the bromine will join with that double bonded carbon atom which contain more number of hydrogen. So that is why in presence of peroxide, the Markovnikov rule become opposite. I mean in presence of peroxide, the negative part of the acid is added with that double bonded carbon atom which contain more number of hydrogen. It is only due to this free radical formation. So if you know about the mechanism, about these two mechanism, I mean Markovnikov mechanism and anti-Markovnikov mechanism, if you know the mechanism, then you will get this Markovnikov rule concept, why the negative is added with that double bonded carbon atom which contain less number of hydrogen, or in presence of peroxide, why the negative is added with that double bonded carbon atom which contain more number of hydrogen atom. So this is about the Markovnikov addition, Markovnikov rule and anti-Markovnikov rule.